Good afternoon, everyone. I'm quite happy to share a bit of use experience of PLEXOS. So I've been using PLEXOS for about 3 years. I started to learn PLEXOS from my role in Western Power as a planning engineer, looking after the transmission and the distribution network planning. And then I move on to those big energy player like BP, and recently in Fortescue, supporting their decarbonization pathways. So today's topic probably is a bit different to the use cases that utility companies and market operators use. So sort of just bring up a different perspective that major industry load, like a major industry customer, how to use the PLEXOS for developing their projects in the LT schedule, as well as doing the islanded operations using their ST schedule. All right, so little bit of disclaimer. So due to the company has quite strict confidentiality, so the topics today we are discussing are mainly just developed on a few standalone mini models, and just to demonstrate the use cases, and they should be easily scale up. And then essentially it's just to support the learning and sharing knowledge of using PLEXOS. So at Fortescue, I'm not sure if people from other states know about Fortescue. So essentially, Fortescue is the #4 miner in the world, headquartered based in Perth, Western Australia. And different to other major industry player, Fortescue embraces a very ambitious decarbonization goal. So essentially, the company is accelerating its decarbonization pathway, and in the best and the most economical way that we work hard towards. All right, so why we chose PLEXOS? So honestly, we have experimented quite a few analytics tool sets. Well, in PLEXOS, basically, the reason we chose it for multi-applications is it has established the libraries across a lot of industries. So for example, electric, gas, heat, those are quite like a pre-established library with the industry-defined units. That's quite convenient to use. But what's mostly special for industry load is the universal. So essentially that allows the miner to establish their value chain from the power to a process. So to a lot of utilities and the market operator, the load and the demand often are not factoring as a decision variable because it's third party. But to industry player, so essentially they have the visibility and the responsibility for both the generation side and the demand side. So given the visibility of our load, our internal load, that also gives our opportunity to co-optimize the whole system value chain and then make the best value out of it. So therefore, in today's session, you may see a few simple examples that utilizes the universal library. So given the support of those libraries, of course, functionally, it supports what we do. And the other thing is, for a large company, a single platform basically creates a better communication channel, and especially to coordinate across the planning sections and the operations sections. And then we trust the engine behind, which is also bespoken solvers in the industry. And in terms of stakeholder engagement, PLEXOS provides quite a transparent way to consolidate all the techno-economic assumptions and the operational requirements. All right, so to summarize, so the use cases, essentially, I think the first 3 categories are mainly from the LT perspective. So essentially is to analyze our mining processes and then identify if there are any opportunities to debottleneck or increase efficiencies, etc. And then to to pair with the process evaluation, it often coupled with technology screening, like selecting vendors and working with the manufacturer OEMs to sort of realize the assumptions. So when we set up a few technical assumptions to achieve certain goals, and we also look for vendors to work on the technology to get those assumptions to reality. So in the end, essentially in the LT space, that's the techno-economic analysis and modeling. So quite a few of my colleagues today attending here, they are the owner of a lot of long-term model, and they support the project development across the world, and also the deep decarbonization pathway in Pilbara. And the last pillar is basically, and also most importantly, is the operations. So we have to make sure that what we envisaged as a possible solution in the end is operatable. So therefore, in the last category, we actually utilize quite a lot of features in the ST schedule. All right, so this is just a very generic value chain schematic. The diagram that represents the mining. It has been simplified to some extent, but essentially this is demonstrated the PLEXOS how to couple the typical electrical library with the universal library. And the green circle essentially represents the electrical node, and all these blue dots are like the flow node, which is essentially the connection points for the mass to join. So people who are not from mining may not be familiar with this process, but essentially, if I'm comparing this process with a lot of recent new energy development like power to hydrogen and to ammonia, you'll find a great similarity between. So it's essentially you have green power assets and batteries paired with gas firming, diesel generators. And then in the middle part is the electrified fleets and the thermal fleets. That's the material transfer. But if I'm comparing to the power to hydrogen value chain, you actually see the electrified fleets is similar to electrolysis. Essentially, you can modularize them and then put on different level of operating level. So essentially, the smart things by introducing the electrified fleets is to creating that load following behavior in the decarbonization world. And that ROM essentially is a physical storage. So if you compare to the power to hydrogen, that can be seen as the hydrogen storage. So often there are questions about what's the trade-off between your power assets and the battery storage versus a hydrogen storage. So likewise, in this mining value chain, it is the trade-off between the electrical energy storage versus physical system storage. Then the OPF, power flow, it's the ore processing facility. So essentially, it's a plant that operates most of the time at a fixed level, but Fortescue is also challenged the limit, so there is some level of demand response, and the flexibility has been targeted in the OPF operation. So then PLEXOS provides those operational related metrics to factor in those constraints and test the feasibility of it. Stockpile, so if you think that's ammonia storage, and train loadout, you think that's a market. So essentially, that's like your power to hydrogen and ammonia value chain, very similarly. But then along this value chain, what are the assets that have been sized, and what are the questions that in the LT mode Fortescue is answering? So essentially, the battery size, wind and solar size, thermal generator PPAs, what's the unit of PPAs that we need to buy potentially, and the sizing for the electrified fleets. Thermal fleets is retiring, and the size of and the level of flexibility along this value chain. Right, so in the end, it's a system co-optimization. So in Pilbara area, so Fortescue actually built the kind of mining hubs, like multiple mining hubs across their operational area. So there might be 5 to 6 hubs and interconnected by 220 kV lines, and then also a lot of distribution network underneath. So therefore, although it is a islanded operation, it's kind of like a mini network that we look after the generation and the demand. All right, so this is just for illustration. So as I said, like how we size the assets. So when we size the power and the battery, we will see what's the dynamics along this process. Then we ask the question, say, what if we can work with the OEM manufacturers to increase the efficiency of the electrified fleet? Then what's the impact from that? So essentially, is if the cost is going down and also the efficiency can be improved, then literally that creates a long duration storage, and as a result, it can reduce the investment in power assets and battery storage. So it's basically, say, system co-optimization. Every part has got its potential opportunity. Right, so then this is a demonstration of how we factor in the operational flexibility. So of course, to purely pursue the economics, we want every component to be having some level of flexibility and having the load following capability. But in reality, there are a lot of mining assets that are designed to be not that flexible. So therefore, we are testing on what if this part is flexible and what if that part is flexible, and see what kind of saving we can generate out of the value chain. But in this case, it is actually something possible because, as I said, like the electrified fleet essentially functionally is like electrolyzer, which is modularized. So they can potentially achieve concurrent charging. So therefore, it allows that charging profile to go ramp up and down following the generation. So given that thought, that we model the assumptions into the system and see what kind of impact to our infrastructure setup. So one clearly observation is the more flexible, they tend to actually introduce the solar and the battery hybrid solution than wind. But if the operation is rigid, given our cost assumptions, etc., that tends to introduce more wind. So which is quite understandable. So if you wanted to overcome the night period while your operation is fairly rigid, then you definitely will need more wind in the mix. All right, so this is another not very conventional use case for using the universal library. So within Fortescue, so we also analyze the reserve, right? So typical reserve modeling that we don't deploy reserve. So reserve basically is like I'm just holding certain capacity there throughout the planning. But in this case, that our stakeholder asked for a simulation for what if I have to deploy reserve and how to model that in PLEXOS, right? So the thinking of deploying reserve essentially is something that can be translated to a controllable load. So in the rationale is they could be deploying reserve under the cloud event when the renewable is generating much less than we thought, then we need to deploy reserve. So in this toy model, essentially, we're using a universal component to synthesize the behavior of deploying additional, ingesting additional load, and that following certain logic. And that logic could be in condition to the weather condition, so like the likelihood of a cloud. So when you have a different likelihood of cloud, that battery will hold a different reserve capacity. And then the dummy load facility essentially is to generate that need for additional load ingested into the system when the cloud is higher. So given that kind of rationale and the reasoning behind, so we can basically synthesize the behavior and also do the simulation and the uncertainties for deploying reserves. So this is a very simple toy model. So the whole model is more complicated, but the story is we're using universal libraries to model the controllable load. Right, so this is another unique use case that we are thinking of, we are progressing with. So in PLEXOS, we found that there is a nice feature that's called non-anticipaticity constraints. So the use case of it typically to me is to address the uncertainties of different weather. So in this case, we're using this feature for the ST, not necessarily the LT, but it can be applied to the LT for sizing under uncertainties as well. So this basically shows that, for example, your wind has a level of variability, and then there is a window that we want that the decision for dispatch to be synchronized. So there's no other no recourse over the period of time on the left side of the right-hand side of charts. And after the dash line, then the recourse is relaxed, then the impact from variable weather will be manifested. So then that essentially is some thought that we are going to use in our so-called security constraint unit commitment. And so we are analyzing, we are utilizing different forecast vendors' results and also internal analysis to generate a range of variability of the weather, and then use PLEXOS to drive the consensus of dispatch decisions. Yeah, so likewise, as I said, like this feature can be used for LT as well to address the perfect foresight of the weather. Right, so it's not very long presentation, but basically just to summarize the use cases that Fortescue used PLEXOS for their project development and the energy operations. Just to summarize the energy, so we have the renewable first strategy, and also we are conducting LT studies to conduct that trade-off between capital and those economics. And then lastly is the operations. So we're sort of on a not very conventional security constrained unit commitment, given the high penetration of the renewables. So we are also exploring we are in the middle of developing those security constraints, the round trip between PLEXOS and the Power Factory or PSSC, the kind of product, to develop those set of stability and the system strength constraints to guide us operating under high renewable penetration. So yeah, that sort of closed out the presentation. And in Fortescue, we have got a list of values. I think using PLEXOS tick the integrity value very well. So just to ensure that we conduct our engineering and system modeling studies in a very to achieve the integrity of the work. Thank you. So. And any questions?
Thank you. You spoke before about the managing, I guess, or lopping demand effectively. Is that something that you then trade off in terms of reduction in productivity and understanding the value of that from your modelling?
Yeah, so essentially it's the levelized cost of production of some commodity, right? So for Fortescue, the commodity will be the ore. So if your levelized cost of producing certain type of the ore, if it is more expensive than the levelized cost of your electricity, so essentially it's the cost of the electricity, then the system will suggest to turn down your load. Right, so that because it's not economical to massively overbuild your wind and solar, etc., while the investment cost, the levelized cost of your production is to increase your levelized cost of production. Yeah, so so in our modeling cases, so you'll see many cases that there will be unit commitment suggesting turning down the OPF or shifting the load for the green fleet charging, etc. So that's another challenge for us to work out the process in reality, how we coordinate all these operations. So these are the things that are still in progress.
Thanks for the presentation. You showed in your in the operational ST modelling that you'd kind of looked at different weather uncertainties and how you manage the operation. To what degree have you done that in the resource planning to help understand the, I guess, a robust mix and what those ratios are and understanding the value of that load flexibility?
So you mean the uncertainty? So
effectively just looking at weather variability in your resource planning.
Yeah, so in the LT space, we are currently not using this methodology to size, but we actually rigorously play back the history. So we do have different combination of weathers so that we get out the size that covers a wide range of variability. But in energy, like especially in the decarbonization and the new energy development, we can't be gold plating or be too conservative always covering the worst case. So in the worst scenario, it will be just turning down the loads. So that's why that probably is something that the island operation has got certain advantage to operate that because they have the option to actually turn down. Then in terms of and the other reason for not using that approach in the LT is generally the LT mode is a bit heavier for computing. So just to shorten the computing time, so we basically deploy more playback the history approach. But when the sizes are locked in the ST mode, so we basically explore the possibility for us to provide more reliable unit commitment decisions for the next few hours or a day. So that we are still in the exploration. But given that stochastic approach, that's sort of using the best information that we have, given different provider like a Ballman and some other vendors, and then that's the best information we get and the best advice out of the feature, and then we are in the middle of designing the digital system to enable the process to happen. Yep.
Sorry, just over here. Hey. Just on your weather traces, so given that you are a relatively remote grid, do you develop all your own weather traces for your wind and solar, or do you use providers to kind of inform what those different weather conditions might be in different forecast years?
I think this part is my colleague may be able to answer that. So it's not in our system modeling scope. I believe the upstream engineering, they have their best approach to provide the historical data traces for representing the historical weather. But Fortescue does invest in installing those wind masks or those devices to capture the best information that we can. Yeah, so, and also the forecasting, we do have experts in the area to work out some internal algorithm, consuming some external providers' intelligence as well.